Okay, circles and parabolas. A circle is a set of all points that are equidistant, which is the radius, from a fixed point, the center HK. So given the equation, notice x minus h is in parentheses. You do opposite whatever's in that parentheses with the x to get the x value of the center. And you do opposite whatever's in parentheses with the y to get the y value of the center. And as defined on your paper, it equals r squared, where r, square root of r squared, which is this r, is the radius. So the first one is in graphing form. You should right now be able to tell me the center and the radius, and then hopefully draw yourself some axes and start graphing it. So they're both in parentheses. Think back to your parent graphs in integrated 3. Anytime it was in parentheses, it ended up being opposite, right? Zero product property. So opposite of x minus 2 is going to give me positive 2. Opposite of y plus 1 is going to give me negative 1. And the 9 is r squared, so r must equal 3. So set up some axes. That makes sense for you. 2, negative 1. So, well, this is really big graph paper, so you should have plenty of space. Center at 2, negative 1. And then you go 3 in every direction. Follow your graph paper. 3 to the right, 3 up, 3 left, and 3 down. Try to draw yourself a nice little circle. Biggest mistake is forgetting to square root that 9, and I get huge circles, which are clearly wrong when I walk by and see your circles. Let's see what's next. Okay, this one is not in graphing form. So you're going to need to complete the square twice. So let's set it up in the not in the margin, but off to the side. Actually, I might end up doing work in the margin so I have enough space. So we have x squared, but I want to group all the x's together. So plus 6x. Then I'm going to complete the square on that. So I'm going to draw an empty square. Then I have the y squared. Group the y's, minus 4y. I'm going to complete the square on that. So I like to use a triangle just to represent the fact that it is a different number. And then I'm going to add the 3. Move the 3, right? In this case, I add it to the other side. Whatever I do to the left, I have to do to the right to keep my equation balanced. So I added a square and I added a triangle. So I need to make sure I do that on that side as well. So completing the square, integrated 2 essential skill. Set it up as x something squared plus, and then this is going to be y something squared, and it'll equal something when we're done. Remember, 6x is the middle term, half of that, plus 3. Then that answer squared is your square. 3 squared is 9. Both squares are 9 to keep my equation balanced. Okay, the middle term, negative 4, half of that, minus 2. That number squared is positive 4. It's always positive. Both triangles are positive 4. 3 plus 9 is 12, plus 4 is 16. Now it's in graphing form, and you should be able to tell me the center, tell me the radius, and sketch it. Pause your video and do all that for me. Okay, check and see if yours matches mine. Opposite of both, so negative 3, positive 2 for the center. And then radius is 4, so I went 4 in every direction, and I graphed my circle. So bookwork and stuff, you might get the radius is like the square root of 12, which I can't do in my head, but I would know it would be like 3 point something, and you can estimate that on your bookwork. For the test, especially if it is free response, expect it to work out nicely, right? Square root of 16 is 4. Square root of 9 is 3. Expect it to be a nice number on any free response test I give you. Anything where you have to graph it by hand. Tangent to, a straight line that just touches a curve at a point. This point is called the point of tangency. That line K is tangent to the circle because theoretically, if I could draw it, it touches at exactly 1 point. Right there is where the line touches a circle, at 1 point. If you put a basketball on a desk, it's touching the desk at 1 point. So understanding that, to do example number 4. Find the equation of the circle with a center at negative 3, 5 and tangent to the y-axis. Let's draw this. center at negative 3, 5. Tangent to the y-axis means it just touches the y-axis at 1 point. So I went 3 in that direction. I don't need to sketch the whole thing because I'm just finding the equation. So before we even did that, hopefully you know a circle looks like this. Don't forget the plus. They gave you the center. So opposite of negative 3 makes it plus 3. Opposite of 5 makes it minus 5. And then now, because it has to touch the y-axis at exactly 1 point, we know the radius is 3, so it has to equal 9, right? For the radius to be 3, it has to equal 9. Okay, let's see what's next. Parabolas. So, depending on when you printed your notes, this... Oh, no, actually, this one came out nicely. Hopefully this one's all on one page for you. If not, I fixed it on my notes so that it would all be on one page. Lots of definitions here. Lots of information. So, a focus is a point inside a parabola. Well, I guess I should do them in order, huh? Parabola is a collection of points, x and y, that are equidistant from a fixed line, a directrix, and a fixed point. So I'm going to highlight and then get rid of it on this because it's already colored in for you, right? See how this distance has a tick mark that is equal to this distance? That's how you get a parabola. You keep the same distance going. I'm going to erase this highlight in a second, but like from here to here would be the same as from there to there. And you just keep going, and that's where the parabola comes from. A vertex is the point on the parabola that's directly between the focus and the directrix, midway between the focus and the directrix. So the distance from focus to directrix is equal to the distance from focus to vertex is equal to the distance from vertex to directrix. Directrix is a line outside the parabola that is p units away from the vertex. So if they just define that as p, then this distance up here is p also. Focus is a point inside the parabola that's p units from the vertex. Just did that one. The latus rectum, or the LR, is a line segment whose endpoints are on the parabola and go through the focus. So it's already orange. This line segment right here, that's going to be how we get 2 more points, right? We're going to know the vertex, and we're going to know the ends of the LR. That's how you're going to get your points to draw parabolas in this class, because they're not going to be in what you guys are used to as thinking of graphing form. The length of the LR is 4p, so that means it must be 2p this way and 2p that way, right? So, line of symmetry goes through the focus and the vertex. You know what the line of symmetry is. Here's what we need to know. We have the graph, the vertex, the focus. If you love charts, here's a chart for you. But I just want you to start thinking about what you already know. If their parabola is opening up or down, right? That's the parabola you learn in like integrated 1 and integrated 2. Those are the ones where x is squared. Both of those is where x is squared, right? Sideways parabolas, if it opens to the right or to the left, those are the ones where y is squared. So that's the first thing you need to start looking at. Is the x value squared or is the y value squared? Then it tells you over here on the side, in a fancy way, I'm going to say it a little easier. The p value determines if it goes up or down. So if p is positive, I'm going to put a positive sign in front of x squared. Well, I don't want it in front of x squared, actually. Positive p. Then it goes up, because positive x's are up. If p is negative, it's going to go up and down. Same idea for the y squareds. If you look at the way your parabola is going, if you go to the right, that's where all the positive x's are, right? So that's a positive p. But if you go down, how about left? When you open things to the left, the x's are negative, and the arrows are pointing to the negative side of the x-axis. That's negative p. Also, please take a look at the way the equation is written. This is standard form in your book. It is not what you guys are used to. So we will be dealing with that on the next page. Okay, so identify the vertex. Okay, let's write some answer blanks. LOS, line of symmetry. LR, lattice rectum. Okay. First of all, you need to figure out if this is going up, down, left, or right. So I just want you to have two options, up and down or left and right. So you look at the variable that's squared. Y is squared. Y squared parabolas are left, right. So I jot that down to myself. This needs to be going left, right. Now I look at the 4p value. 4p is negative. Negatives are to the left. This parabola is opening left. Okay, vertex comes straight out of the parentheses just like before, but pay attention to where the variables are. X minus 1, opposite, gives me positive 1. Y plus 2, opposite, gives me negative 2. Okay, remember the yellow highlighted number is 4p. 4p equals 8. We don't care about the negative. The negative means it's going left. So I guess over here, if you wanted to, you could put absolute value bars around your length because a length is always positive, right? So 4p equals 8, divide by 4, p is going to equal 2. So that means the focus is to left or right of the vertex, and the directrix is to the other direction of the vertex. So maybe we should start sketching this one. So 1, negative 2. So I've got plenty of space on my graph paper. Okay, so 1, negative 2 is the vertex. We know this is opening left. We made that decision earlier, right? So left is the way it's opening, which means the focus needs to be inside the parabola. So the focus needs to be left. It needs to be 2 to the left of my point. So 1, 2. That puts it at negative 1, negative 2. Negative 1, negative 2. The directrix must be 2 in the other direction. So 2 the other way. Directrix is an imaginary line, so we'll draw a dotted line for our directrix. Equation of the line for the answer blank. That line is x equals, and it's going through 3, so x equals 3. I'll do my line of symmetry in a second. So I know where my vertex is, and I know what my parabola is doing. Now I need to draw in the LR. Remember, the LR is 4p. It's that positive 8 because it's a length. So that means through my focus, remember my parabola is, let me just sketch this in real quick. This is not going to be correct. But in general, my parabola is doing that, right? Through my focus, the length of the LR is 8. So that means I split it in half. I'm going to go 4 up, that would be a point, and 4 down from the focus. Now I have 3 points, and I can sketch my parabola much better. Try to hit the points. This distance was 8. And my line of symmetry goes straight through the vertex. The vertex has an x value, the line of symmetry, we don't usually draw it, but I will draw it for you guys, goes straight through the vertex. In this case, it's a horizontal line. That horizontal line has a y value of negative 2. Something to notice. This graph was a left-right graph because y was squared. And look at how the y values are the same in every single answer that has a y value. Something to keep in mind. Let's see what's next. Okay, completing the square first. This one is not in standard form yet. So I'm going to do my work in the left. Whenever possible, keep x squared positive. So I'm going to keep x squared. You guys understand that I can move this equal sign and put it over there, right? So I'm going to keep the x squared and the minus 2x. But clearly it's the x that's squared, so that's the one that needs to be complete the square with. And then I want to move everything else to the other side. So in this case, I need to subtract 4y and subtract 9. But I'm completing the square, so I need to add the same box to keep it balanced. Okay. Practice completing the square. X something squared. Middle term is negative 2x. Half of that is negative 1. Squared is 1. 1 for both boxes. Negative 4y. Negative 9 plus 1 is minus 8. This is still not in what you're now going to learn as standard form because it does not have a single positive y. So I'm going to keep x minus 1 squared, but I need this side to be a single positive y, which means I need to factor out negative 4, and when I divide by negative 4, I get plus 2. Now we should be able to figure out some of our answer blanks. So we're going to need vertex, focus, directrix, LOS, and LR. If you're ready, pause the video and see how many of those you can answer. You should be able to answer vertex. Pay attention to where the x's and the y's are. Opposite the thing with the x is the x value. Opposite the thing with the y is the y value. We should also look at this equation now. Is this going left, right, or up, down? So narrow it down to 2. Because it's x squared, hopefully you're thinking up, down. Now, which one of those? Because your p is negative, hopefully you understand that it's going down. So I like to start sketching it. Once I know the vertex, I guess you could work on finding p, but I'm going to set up my axes. Go ahead and find p if you're ready. My vertex is 1, negative 2. Okay. Remember, 4p equals positive the number, because the LR, and that's actually the answer to LR, is a positive length, so it's 4. But divide to get p. P is going to be 1. So from my vertex, we decided this is going down. So I'm going to go down 1 from my vertex. That's going to be inside. Again, let's sketch this in real quick. It's doing this, right? It's opening down. So that's my focus. My focus is inside the parabola, and that puts it at 1, negative 3. And I'm going to go 1 up, and that'll be my directrix, the line. That's a horizontal line. That's the equation y equals 1. What's happening? Clearly that's negative 1, right? Sorry. Then I know my LR is 4, so I'm going to split it in half equally. 2 left of my focus, 2 right of my focus, and that's my parabola. Line of symmetry, if you love to draw it, it won't be drawn on multiple choice test questions, just so you know. X equals 1. This one was going down. It had x squared, and notice all the x's have the same answer. Okay, going backwards, find the equation. So I gave you a graph paper for a reason. It's highly recommended that you sketch these out. Even if you don't set up axes for yourself, I just think it's so much easier if you sketch them than if you try to use a formula or figure it out that way. So let's see. We have a directrix at y equals negative 1. Dotted line. Y equals is horizontal. And a focus at negative 2, 5. That's the focus. So in general, my parabola is doing this, right? Because the focus has to be inside the parabola. But if that's my directrix and focus, I should be able to find the center of that, right? You can count it out on graph paper, or negative 1 plus 5 divided by 2. That's how you find the middle of things, average them. 4 divided by 2, that's going to be 2. So my focus is, my vertex is there. And once I know my vertex, I can plug it in. So one of these should be squared, and the other one will have 4p in front. If my parabola is opening up, which one should be squared? X should be squared if your parabola is opening up, so that means y is over here. If I know my vertex, we just figured out the vertex together, right? It's negative 2, 2. Put it into the equation. Minus 2 becomes plus 2. Positive 2 becomes minus 2. Then I can see p, or I can count. P is 3, right? It's 3 from the focus to the vertex, or 3 from the vertex to the directrix. So remember, 4p is what goes in front. So 4 times 3 is 12. But that's always going to give you a positive answer. You have to stop and think, should it be positive or should it be negative? This one's opening up, so this one should be positive, and this is the equation of our parabola. Okay, so hopefully this helps you a little with circles and parabolas, and I hope you're doing well.